true and false, false and false. For all of the other three, the answer is false, which is consistent with the way that we normally use the word and. Yep?
Not to digress or take up too much time, but when the exam time comes, do we need to be able to work the equations, or do we also need to be able to define the terminology?
When exam time comes, what usually happens is I will give you the piece of code to trace. So I'm going to test, do you understand how that code works?
So we don't need to know the definition of a conjunction as an operator that has two.
Yes, you do. Yes, you do. Because you need to be able to read my code.
But you're not going to have matching or multiple choice that has us pick.
I will give you the code, you tell me what it's going to do. So in order to do that, you have to understand all the notations.
Yeah, I get that.
Yep. So this is conjunction, and this is disjunction here. So disjunction is the same thing as the word or. The only time a or has a result of false is when you have false or false. For all the other three cases, true or true, false or true, true or false, the answers are all true, which is also consistent with the way that we use the word or. But it is not either or. Okay, this is just a simple or, not either or. The last one is negation, which is the English word not. Okay, this one is rather easy. Not true is false, and then not false is true. And that's it. We're just flipping the answers. We're flipping the polarity of the word. Okay. So now we have, a slightly different implementation of the logic using the word, using else if here. So what else if really is embedding the second if inside the first if. So if you want to look at the picture of the else if mechanism, there's a picture of that. Like that. So you have the first if, the first condition of the first if, and then the else if, the second condition, is here. In other words, we don't even evaluate the second condition unless the first condition evaluates to false. Is that okay or not? Mm-hmm. Okay. So this picture corresponds to, oops. Okay, I take it back. This picture corresponds to this pseudocode, more or less. There's a little bit of difference here. This is greater than or equal to. The other one only uses greater than. Yep, go ahead.
I was just going to ask just that. Why this discrepancy between the symbols?
I cannot remember why. Actually, this one is representing the algorithm 3. So, yep, they are slightly different. But I think I fixed the code of the pseudocode, but the picture was drawn already, so it was a much more difficult thing to update. So when you look at the picture, just update the picture to greater than or equal to instead of greater than. It's much harder to draw the picture than it is to write the code. Yep.
Is there a reason, I know you mentioned that true false doesn't really hold much weight, but is there a reason why we couldn't do if for true and then else for false? Like in the first two branches, if it's true, then why not replace true with if to kind of keep the like when you're reading the pseudocode.
Oh, I see. The labeling of the branch. Yeah. So why not labeling this to if and labeling this one to false? That's a good question, but the answer to that question is when we talk about loops. Because when we talk about loops, there's no if then anymore because you're going back to an earlier place. So there's no proper name to name that branch except for is it true or false. Besides, each one is representing an answer to the question. So that's why they're labeled true or false, because it depends on how you answer the question of this on this post. Yep.
How do Booleans fit into this? Because I know we talked earlier about Booleans being true or false.
Right, right.
How does this represent it in like an if-else statement?
Well, it is still true or false, right? Because when you look at a conjunction, the result of a conjunction is still only true or false. It cannot be any other value except for true or false.
So this would be considered a conditional statement and not a boolean?
A conditional statement relies on conditions. The result of evaluating a condition is a Boolean. So Boolean is kind of a type. It's kind of a restriction of what kind of an answer a question can have. And then a condition is basically a question that ends with an answer of either true or false. A conditional statement is a branch where you ask a question, where you have a condition. Depending on the answer to that question, you go one way or the other. So that's kind of the relationship between a Boolean, a condition, and a conditional statement. So is that part okay? Does everybody understand that part, or do you want me to kind of go over that one more time? One more time? Okay. All right. So we can just look at this picture too. So this is a conditional statement or nested conditional statement because we have basically this is the nested part. The result or the answer of this question has a Boolean value, which means the answer to this question is either true or false. Because the question is w greater than x and w is greater than y true or false? So the answer is either true or false. So that means the type of that answer is Boolean. This thing by itself, the question itself, is called a condition. It is an expression that ends up with a Boolean value. The construct here, where you can branch one way or the other and how the branches are going to merge at the end, is the conditional statement, otherwise known as an if statement or if then else statement. So is that helping to kind of clarify the relationship between those terms? Okay, excellent. Excellent. All right, so before we end this class, for sure, we want to be able to trace this code. So now we need to go ahead and write this code and then trace it with a spreadsheet. So why don't we use something that we have done already, which is this thing here. So I'm going to erase the C code because that is not the focus of this class. So we'll use this pseudocode here. And then we'll trace it using a spreadsheet. And I think I have a spreadsheet already here. So we'll go ahead and use the same spreadsheet, except we'll start a new sheet. So this way we don't confuse several answers to the same thing. So we are using a new sheet here. Line number, we have, how many variables do we have this time? 4. W, X, Y, Z, there are 4 variables. So we got W, X, Y, and Z. You cannot see it because I just scrolled off screen. Okay, so we'll shrink these columns so that it's easier to see everything. Okay, so shift click. There we go. All right. And let's go ahead and have some precondition here. In other words, we are going to put some values, quote unquote random values, into W, X, Y so that we can track down the algorithm to find out what it's going to do. So I'll let you guys pick. What do you want to use for W? 1, 2, and 3? Okay, so let's do that. 1, okay, 2, and 3. Okay. What about Z? Does it really matter what you put into Z at the beginning of the code? Why not? It's going to be changed, assigned. It's going to be altered or updated anyway. So we'll just say that we don't know the value of Z to begin with. We'll put a question mark here. It doesn't start with any particular value. Okay? Or we can say it starts with an unknown value. All right, so how do we trace this code? With a conditional statement, it's a little bit different compared to a assignment statement because most of these lines does not actually change anything. Okay, they're only evaluating condition and decide which way to go. So what we do is we still have to say that we are evaluating line 1. But what we'll also do is we have to now insert a new column to the right, nope, to the left of this. And we'll call this the condition. Okay, the condition or comments, I usually just use the word comments, to basically indicate what is the result of evaluating a condition. So on line 1, we want to say, what is that condition evaluating to? Is it true or is it false? The w is greater than x and w is greater than y. It's false. Okay. So we say the shorthand is just to say false, but I'm going to write down the whole thing. W is greater than x and w is greater than y is false. Okay. Then where do we go? What is the next line that we're going to go after line 1, knowing that the condition is false? So we would say that we usually say that we do not use 3, okay? Because line 3 doesn't actually do anything. It is it's more or less a bookmark. It's more or less a marker to say that, oh, here's the beginning of the else branch, but it doesn't really do anything. What is the next line that actually does something? Line 4, very good. So line 4 is typically what I trace. But if you want to say line 3, in your answer, I'm not going to mark it wrong. It simply doesn't do a single thing, and it just uses up one line in a trace. So line 4 is another condition. It asks the question, is x greater than y? Is it true or false? It is also false. So that means where do we go next? We go to line 7, because line 6 doesn't do a single thing. On line 7, what do? We evaluate the right-hand side, which is y. Y has a value of 3, and then we put it into z. So when I put it over here, so z is no longer a question mark, because now it is updated to a value of 3. And then where do we go? That's it, exactly. Because technically speaking, we first hit the end if of line 8, and then we hit the end if of line 9. But end if doesn't do anything. Okay? End if is once again a marker to indicate the end of a conditional statement. By itself, it has nothing to do. So we do not trace those lines. As a result, we get to post, which means we're done. Is that okay? So we can see how the flow goes, with this particular code. Okay, so do you guys want to try another example? No. False. False. Is it true or false that we want to evaluate another example? False. Not true. Okay, so I'm just copying and pasting here. Okay. I think we should probably do maybe 1 or 2 examples, just so that we know how it works. Okay. So I'm going to try something. What if they are the same? Okay. So we're going to have 3, 3, and 3. Make this column a little bit wider because it needs more space. Okay. So once again, we start with line 1. And then we use the comments column to indicate the answer to the condition. All right, so someone can tell me whether w is greater than x. It is false. Okay, so w is greater than y is false. And then where do we go next? Sorry? Line 4, very good. And line 4 evaluates the second condition, which is x is greater than y, which is also false, right? So we still end up with line 7. Line 7 still has that one thing to do, which is copying the value of y to z. So z now has a value of 3, and we are done. Okay, that doesn't sound too bad. Okay, one more time. But this time, let me ask the question in a slightly different way. In other words, instead of me telling you what values we are starting off with, I'm going to say, what if I want to execute line 5? What will trigger this code to execute line 5? Hmm?
The x has to be anything above 3 right now.
So x has to be the larger one, largest of the 3. Okay, so what do you want to make it? 4. Make it 4? Okay, 4 is fine. Okay, that's all cool. So we'll now shrink the columns a little bit just so that everything will fit. Okay. And then we can now put this on the side so we can actually show the code. Line 1. Okay, we have w is greater than x and w is greater than y is false. Okay, so we go to line 4. On line 4, x is greater than y is true. Then where do we go? We go to line 5. Line 5 is going to copy x to z. So z now has a value of 4. And where do we go next? Post. We're done. Okay? All right, so there's only one branch that we really have not exercised, right? Because we have exercised the branch of line 5, the branch that is line 7, the branch that is line 2 has not been exercised yet. Well, might as well do it, okay? So let's go ahead and create one more test case just for that. So paste. Reformat. And change this column to be a little bit wider. And this will be the shortest trace of all the traces. So we need to exercise line 2. What will make this code execute line 2? When w is greater than the other 2. So let's make w 4 this time. Okay. All right, so here we go. Line 1. We evaluate the condition. W is greater than x, and w is greater than y is true this time. So we execute the then branch of that condition, which is on line 2. W is the right-hand side, z is the left-hand side, so z is updated to a value of 4 because w has a value of 4. And where do we go next? Post. Done. Oops. I shifted the keys a little bit. There we go. So that's how we trace a conditional statement. Are there any questions about how we trace a conditional statement? So any line that has a condition to evaluate that is on the path of execution needs to be traced. Any line that actually has a side effect of changing a variable needs to be traced. Else is not traced, and if is not traced, because those actually do not do anything. Now, if you write those lines along in the trace, I'm not going to take any points off, but there's no point in tracing those lines. So are we good so far with conditional statements? Okay. So we can get a head start on loops. Okay. Loops are very useful, sort of. Maybe. There are programming languages without loops. But most practical programming languages do have loops. Okay? So the title of this particular section, what is a loop again, is actually a play of the words. Okay? Because the use of the word again implies looping. Okay? So a loop is a control structure that allows certain steps in a program to be repeated, to be performed over and over again. It allows what we call iterations. Why is that important? Now that we have conditional statements, why do we need loops in addition to conditional statements? Yep.
You want to repeat data more than once?
And why do we want to repeat something with an undetermined number of times, usually? Yep. Go ahead. Okay. What do we do on a daily basis that actually is a loop? Sleep.
Checking your alarm clock and going back to sleep.
Okay, so tell me about the condition of that one. How do you get out of that loop?
If it hits a particular time, you get up or snooze.
Then why don't you just set that time as the only alarm time so you don't have to do it in the loop? I see. Okay, that's an honest answer there. Okay, but there are many other things that we do that is actually inherently a loop. Okay, how many? Yeah, go ahead.
Like driving. You see a red light up ahead and you check, am I close enough to start braking? And then you get to that, you check, and then as soon as you get to that point, you go, okay, now it's time to start braking.
Okay, but is that a loop? Kind of. Okay. Yep. Oh, wait. Okay, him first and then you. Okay, what was that? Breathing? Well, breathing hopefully is an infinite loop. because you have to think about okay, this is really important. Every time you think about a loop, you think about when do I stay in the loop or when do I get out of the loop. So if breathing is in a loop, then what is the condition to stay in the loop and what is the condition to get you out of the loop? Huh? Staying alive. So okay. Anything else? Yes.
So you have the example for eating, but in reality, anything's a loop until the condition is satisfied.
Yes.
Doing that behavior.
Yep. Well, not everything is. There are certain things that are conditions only, but not a loop. Go ahead.
I was actually just thinking about eating.
Eating.
Until we're full or satisfied, and then we stop.
Yep. But there's one more that I can use as an example, and this is a really kind of interesting one. Channel surfing. Now, I don't know really how many people still watch TV. Do you guys watch TV anymore? I don't watch TV anymore. I go to Costco, and the DirecTV people would walk up to me and go like, oh, we have a really great discount on, DirecTV, and you can get all of these discounts, and go like, I don't watch TV anymore. The guy goes like, then what do you do? If I want to, I just go to YouTube or some other places. I only watch what I want to watch. But in the good old days, Sorry? No.
You say what? Channel surfing is not there anymore?
Channel surfing doesn't apply to me nor anyone in my household anymore because we have a 32-inch TV in the living room, but it has not been on for like at least 6 months. No one watches TV anymore. We just use our phone like that. Yeah. But in the good old days of channel surfing, okay, what is the loop? What are you doing repetitively? What is in the body of the loop that you're doing repetitively? Pressing the button. Which button? Channel up, right? Yep. Change channel. Channel up or change channel.
You're not together anymore. It's just individually.
Doing channel surfing?
Yeah, you're not.
No, I don't do channel surfing. I wait. I know exactly when the next episode of Doctor Who is going to be released. I'm not going to do anything until that time.
But it's fun when you're with people. When you're by yourself, that's not cool. You're just by yourself.
Yes. It's perfectly cool to be by myself. Yes.
Does everybody feel this way in this room? Because I guess I'm by myself. Because I love to be with people.
Aha. Go ahead.
A look for you is that every class we have a break, you always go get some coffee?
Only when I'm feeling a little bit, low. Yeah. A little slow. I need that to overclock, so to speak. Okay, but anyway, what is the condition to get you out of that loop of channel surfing?
Be with people?
Being with people?
How about being in the real world for a minute? For 1 minute, just be there.
I'm here.
I don't know.
Well, I don't know whether you're a simulation or not, so I can't really tell whether I'm actually in the real world. But
You're in the Matrix right now? Am I Leo? Should I start fighting people? Like, I'm confused.
I don't know whether you are in the real world or not. But in the loop of channel surfing, what is the condition to get out of the loop?
Be with people.
Find something you like.
Whoa.
Exactly.
You guys, I'm sorry.
Okay. So, yes, so he was right. Okay, so when you find, can you let me finish?
Okay.
Thank you. So when you find a channel that you like, then you meet the condition to get out of the loop. But conversely, I can ask the question, what is the condition to stay in the loop?
You don't
when you have not found the channel that is interesting. So you keep pressing that button. Okay? So every time we get into the concept of a loop, there are two main questions to ask. What are you doing repetitively? And what you're doing repetitively must have something to do with the condition to either stay in the loop or to exit the condition, exit the loop. So those are the really, really, really important concepts. You know, if the condition has nothing to do with what you're doing in the loop, then you might have a problem. All right? So we are almost there in time, so I'm gonna let you guys go, you know, like maybe 30 seconds ahead of time. I'll make that up next time. Oh, we got a new subscriber.
Have you seen the Goonies?
The what?
Have you seen the Goonies? The Goonies?